James Webb Space Telescope, or JWST, is often described as a replacement for the Hubble Space Telescope, and it's understandable why. The images that have been coming from JWST since its first observations were released in summer 2022 have been incredible, uncovering amazing detail never before seen from galaxies and nebulae, and revolutionising our ability to understand what exoplanets are made of. But as a telescope, JWST is quite different from Hubble. The Hubble Space Telescope detects light of a similar wavelength to our eyes, mostly detecting visible light with a bit of the near ultraviolet thrown in too. Webb, on the other hand, observes longer wavelengths of light, ranging from the far red end of the visible spectrum out to the mid-infrared, covering a wavelength range of 0.6 microns out to 28 microns. And yes, that means the blue in this image isn't really blue. It's some infrared wavelength that scientists have displayed as blue so that we can understand the differences between different wavelengths better. Anyway, since JWST observes at almost completely different wavelengths to Hubble, it can't really be considered a replacement for Hubble. But why can't it? Why can't the James Webb Space Telescope observe invisible light? My name's Thomas Rintoul. I'm a PhD student in astrophysics at Cardiff University, and that's what we're going to talk about in today's video. But before we go any further, please consider subscribing and hitting the bell icon so you don't miss future videos. The easy answer as to why JWST can't observe visible light is that the engineers that built it just didn't bother to add any detectors for it. But that's not a very satisfying answer. When you build a space telescope, every decision made is made for a reason. So what's the reason behind the decision not to add a visible light detector? Well, first off, JWST is already a really complicated telescope. It's got the largest mirror ever sent into space that's split into 18 hexagonal segments. It's also got 4 infrared detectors on it already, which all add weight and complexity to the telescope. At shorter wavelengths, JWST has NIRCam, NIRSpec and NIRIS, a camera, a spectrograph and a third instrument that's a kind of a specialised combination of the two. These 3 instruments all observe at wavelengths between 0.6 microns and 5 microns, the near infrared. The 4th instrument is called MIRI, the mid-infrared instrument. This is another combined camera and spectrograph capable of detecting light between 5 and 28 microns in wavelength. But this still doesn't really answer the question of why we couldn't have a visible light detector as well. Why is JWST so focused on the infrared? The reason for that is due to an interesting quirk of the universe. It's expanding. As the universe expands, light from distant objects gets stretched, so we detect it at longer wavelengths than it was emitted at. This is called being redshifted. To observe the most distant galaxies, we need detectors that can see these longer wavelengths, detectors in the infrared. And to see the most distant and faintest objects, we need to collect as much of that infrared light as possible. So that brings us back to the mirror. I've already said it's big, 25 square meters big, and its surface is coated with gold. Wait, why is its surface coated with gold? Aren't most mirrors, more silvery? The reason that JWST's mirror is coated with gold is that it's a brilliant reflector of infrared light. At the wavelengths that JWST observes at, polished gold reflects 96 to 98% of the infrared light that hits it. We see this in the mid-infrared, the near-infrared, and the longest visible wavelengths. But as we go to the shorter, visible wavelengths, that reflectivity drops to about 40%, going even lower as you head towards the near ultraviolet. This is why JWST doesn't have any visible light detectors. Because its priority is infrared light, it's just not that good at collecting those shorter wavelengths. It would be a waste of time, complexity, and money. However, that mirror is huge, so just for fun, how much worse than Hubble would JWST have been if we put a visible light detector on it? Well, the telescopes are very different, so it's not exactly a like-for-like comparison, but let's start with Hubble. Hubble has a 4.5 square metre collecting area on its primary mirror. This is the light bucket. It also has a secondary mirror. In both cases, the mirrors are coated in polished aluminium, which has a reflectivity of around 90%. This means that around 80% of the light collected will make it to the detector after being reflected off the two mirrors. JWST, on the other hand, has a 25 square metre collecting area on its primary mirror, 5.5 times more than Hubble. But it has 3 gold-coated mirrors. Taking that 40% reflection 3 times means that only 6% of the visible light collected by JWST would even make it to a detector, which, even accounting for the larger surface area, doesn't even get you half of the visible light that Hubble detected. Its inability to detect visible or near ultraviolet light really means that JWST is at best a successor to Hubble, still capable of producing amazing images and doing some absolutely outstanding science. Like, seriously, outstanding science. There are papers coming out with JWST data literally every day. But it's an infrared telescope. It's a different beast. It's a successor, not a replacement for Hubble. The replacement for Hubble is on the way though, with the Habitable Worlds Observatory due to launch in the early 2040s. This is a really exciting upcoming telescope, so please like this video if you want to see a video about it in the future. I hope you enjoyed this video. I've wanted to know the answer to this question for a while myself. I wasn't really expecting the answer to be the gold coating on the mirror. Like, I knew there had to be a reason. I'm just really glad I know what it is. If you enjoyed this video, come join our community Discord at the link in the description. It's full of like-minded space nerds and it's a great place to hang out and chat. If you're looking for something else to watch, there's some recommended viewing on screen now, and all that leaves for me to say is thank you very much for watching, and I'll see you in the next one.